Welcome to The Explainer. Today, we're going to dive into a powerful and, frankly, a really beautiful new way to understand artificial intelligence. We're going to connect some ancient philosophy to the absolute core of how this stuff actually works.
So, you've probably heard the standard line a million times. Large language models just predict the next word. And look, technically, that's true. But it just feels like it's missing something huge, doesn't it? It's kind of like calling a grand cathedral just a pile of stones.
To really get what's going on inside these models, we have to look deeper. The words you see popping up on the screen, that's only half the story. Underneath it all, there's this fascinating ancient pattern playing out. And that pattern is all about a core duality, right? A split between the messy, imperfect world we can see and the clean, hidden structure that's actually creating it. This is an idea that has been echoing through human thought for literally thousands of years.
And here's where it gets wild. Look at this. We're connecting three totally different fields: ancient philosophy, modern math, and cutting-edge AI. Whether we're talking about imperfect objects versus their ideal forms, or messy vibrations versus pure modes, or even the words you see versus an AI's hidden structure, we're looking at the exact same idea.
So let's start our journey way back, over 2,400 years ago, with one of the most famous ideas in all of Western philosophy, Plato's allegory of the cave. Plato had this idea that every single chair you've ever seen is just an imperfect, flawed shadow of one single, perfect, ideal form of a chair. The real deal, he said, existed in this hidden realm of perfect forms, and that's what casts the very shadows that we live our lives in.
Okay, so, stick with me. We're about to build a bridge from philosophy straight into mathematics. We're going to connect Plato's forms to this powerful concept called eigenstates. And don't worry, we're keeping the equations out of it, I promise.
Yeah, forget all the complex math. Just think of an eigenstate like a system's favorite song. It's its natural, pure pattern, a mode that it just resonates with. It's a state that doesn't get all jumbled up into a messy noise.
And this quote just nails it. Think about a violin string. You can pluck it and get all sorts of messy, complex sounds, right? Those messy sounds, those are the shadows on the cave wall. But that string has a few pure natural notes that it wants to sing. Those are its eigenmodes. Those are the underlying forms.
And boom, this brings us right back to the heart of how large language models really work. Because guess what we find inside an LLM? This exact same duality. This split between the messy surface and a hidden, structured reality. For an LLM, the words you actually see on your screen, the tokens, they're just the shadows. The real action, the real show, is happening in a vast, hidden geometry of meaning, a place that engineers call latent space.
You see, the model doesn't handle words like simple dictionary definitions. First, it turns every word into a coordinate, like an address on a massive, multidimensional map of meaning. And from there on out, it's all about geometry. The model is just operating on these locations, navigating this incredibly structured space of relationships and concepts.
Okay, let's really dig into this, because when you start to see LLMs this way, it gives us a whole new, powerful vocabulary to describe what's actually going on. It really reframes everything.
Now, this hidden world, it isn't some perfect realm of ideal forms like Plato imagined. It's more like a probability cathedral, where these form-like structures have emerged, they've crystallized, just from being trained on unbelievable amounts of data. It's a space where some meanings are just more likely, more stable, more natural than others. So get this, when you write a prompt, you're not coding. You're not giving it rigid instructions. You're more like a navigator, a tour guide. You are coaxing the model toward a certain neighborhood in its vast inner map. You're steering it into a specific mode of thinking. And then, as the model starts generating text, it's doing the reverse. It's taking all those abstract pressures and concepts from its hidden world of form, and it's casting a new shadow back onto our cave wall for us to see. And that shadow takes the form of the next word.
So the crucial point here is that this totally reframes our whole understanding of this technology. It's not just some surface-level trick. It's a deep, cyclical, beautiful process.
The LLM's full operation is this amazing round trip. It starts with a shadow, an input word. It then ascends into this world of abstract form. It navigates all the probabilities and pressures in that space, and then it descends from that form back to a new shadow, the next word. But, and this is a really important but, these are not Plato's forms. His were perfect, timeless, descended from some heavenly realm. And LLM's forms are learned. They're statistical. They're approximate. They aren't fundamental truths of the universe. They are stable patterns that have literally precipitated out of the data.
And this is why just saying, "it predicts the next word," completely misses the point. The magic isn't just in predicting the final word. The magic is that to do that job well, the model first had to build and learn to navigate this incredible inner world of meaning.
And this leaves us with a truly profound thought. Maybe, just maybe, we've built machines that are showing us something fundamental about intelligence itself. That abstract understanding doesn't have to be handed down from on high. Maybe it can just emerge, precipitate, and crystallize directly from experience. It really makes you wonder, what else is hiding in the shadows?